Hola, buen día. Hoy les voy a repasar la práctica 3, que es Mecánica de Fluidos. Esta práctica nos tocó traducirla al inglés y dice: Thematic Units 2 Wave Motion. Particular Complexity. Analyze the basic concept of wave motion by observing its characteristics, measuring it by means of instruments, and verifying the equations that explain this phenomenon. Practice number 3, Mechanical Waves. Competency element: analyze mechanical wave in different media using settings, waves, and instruments, and check the formula describing the propagation velocity of these waves. Introduction: a mechanical wave can be defined as the propagation of a disturbance in a mechanical medium. Recall that when we move a threaded rope at one end, the movement propagates along the rope until it reaches the other end. It is important to know the values of the velocities of propagations of mechanical waves in different media signs. This value depends on the properties of the medium, and in many cases it is used to determine properties of the medium, such as the linear density of mass of the rough detention to which it's subject. To determine the propagation property of mechanical wave in different media, we will use the standing wave technique. The standing wave is formed in a medium of a given length when a traveling wave propagates through it and is reflected on one end, returning through the same medium. From the superposition of the incident and reflect wave, the standing wave is formed, which has this name because when observed it seems not to move. Additional information: the fundamental form for the determination of the propagation velocity of a wave is where lambda is wavelength and f is the frequency of the wave oscillations. The frequency of the wave oscillations can be determined from the value displayed on the frequency generation. The unit of frequency is hertz, or cycles per second. For the determination of wavelength, we must observe the figure that forms the standing wave in its movement in the case of string. Analysis of system with a horizontal string. Procedure: observe and install equipment and listen. Turn on the function generation and set a frequency value close to 0. Observe if and how the medium rope oscillates. Note the characteristics of the oscillation of the points of the medium string. If the oscillation and the direction of the wave are perpendicular, then the wave is a transverse wave. But if the oscillation and the direction of the wave go in the same direction, then it is a longitudinal wave. Slowly increase the frequency value given the medium string. Time the installation, the oscillation mode, and when an oscillation mode is formed in the string, file in the following table. Note: use the amplitude node to establish the systems. And turn on the function generation and set a frequency value close to 0. Increase the frequency value slowly given the medium. Time to establish the oscillation mode, and when an oscillation mode is formed in the spring, fill in the following table. Observe the behavior of lambda and the frequency in each of the cases. Research Report. Observe the behavior of the value of velocities with different frequency and mode of oscillation. Describe what you found. Give 5 man-made situations where mechanical waves exist. Give 5 situations made binatural where mechanical wave exist. Fundamental questions.